Hey guys, I hope you did well on your quiz just now. I am remaking this video because it got lost apparently last night while it was loading. So what we're going to do today is we're starting our exponentials and logarithms unit. So we're mostly going to focus on logarithms, but to understand what a logarithm is, you have to understand what an exponential is. And we've worked with exponentials before, okay? So here's a warm-up. I have 2 raised to the power of x. So now my exponent is the variable. Okay, this is an example of an exponential function. So to complete this t-table, we use, excuse me, we can use a calculator, or we can use your brain to fill in these pieces. So if I have 2 raised to the negative 2 power, if you type that in, it is going to give you a 0.25. Okay, I do want you to know why it's 0.25. Okay, because 2 to the power of negative 2, exponential rules means that that negative exponent drops down at the bottom, so it becomes 1 over 4, which is 0.25. All right, having a negative 1 exponent, same thing, it makes it drop down. 2 to the power of 1 is 2, which is 0.5. Anything raised to the power of 0 always equals 1, no matter what the value is. So the 2 is the base. So if your base was like 10,000,001, okay, but it's raised to the exponent of 0, it's equal to 1, all right? So that is always going to give you a 1. 2 to the power of 1 is just 2, and then we know 2 squared is going to be 4, okay? These are exponentials. This is what we're going to be working with today. We're going to explore how to type them into a t-table and just looking at their graphs, okay? So here's our first one. So we have stuff already written here from the last video. See, told you. All right, there we go. I have gotten rid of my markings. So we're going to make a t-table. This time the function is now 3 to the power of x. So we're going to change our exponent to negative 3 up to positive 3. So 3 to the negative 3 power, it means the negative exponent is going to flip over, okay? So it becomes 1 over 3 cubed, which is 1 over 27, which is the same thing as 0.037. Do the same thing for negative 2. 3 to the negative 2 power becomes 1 over 3 squared, which is 1 over 9, which is 0.1. 3 to the negative 1, okay, so it flips down. 1 over 3 to the power of 1, which is 1 over 3, which is 0.3. Anything to the power of 0 is 1. 3 to the power of 1 is 3. 3 squared is 9. 3 cubed is 27. So we're just filling in our t-charts, okay? If you have a graphing calculator, let me show you what you could do there. Okay, so if you have one of these guys, okay, you can also get your table on this. So you're going to push the y equals button in the top left corner. All right, and then you're going to, for this one, I'm going to do 3, the number 3. We're going to raise it up. So there's a little caret symbol right here. We're going to raise it up. And then for the x, we're going to use this variable button that's next to your green alpha button, like that. And so your screen should look like that. Once we have it in the place, we're going to go to our table, which is over here. So I'm going to push second table. All right, and we have all of the pieces that we need. So we could use a graphing calculator also to get our values. All right, not necessary though. It's a cool tool, but we can obviously do them by hand also. All right, let's graph this so we can see what these graphs look like, because when we get to logarithms, they're going to be the inverse of it, the opposite. So with this one, when I plot my points, we start very low, very close to the x-axis, and then it jumps up very quickly. Okay, this is called a J-curve. You might have heard it called a J-curve in the past. All right, so that is 3 to the power of x. Let's do 1/4 to the power of x. Okay, so again, you can use this if you want to. Go back to your y equals. Change your 3 to a 1 divided by 4. Make it look like that. I would put it in parentheses. And then you can go to your table and get your same values. Again, I'm also going to show it to you by hand. So 1/4 raised to the negative 3 power. All right. So we're going to have 1/4 to the negative 3. Remember, the negative means that we're in the wrong spot, right? That the whole fraction is flip-flopped. So that's actually going to be 4/1 to the power of 3, which is 64. Same thing with 1/2. If I have 1/4 raised to the negative 2 power, fraction flips to get rid of that negative exponent. It becomes 4 squared, which is 16. All right, 1/4 to the negative 1 power flips over, becomes 4 to the power of 1. We have 4. Anything raised to the power of 0 is 1. 1/4 to the power of 1 is just 1. 1/4, right? We give the exponent of 1 to each piece. 1/4 to the exponent of 2, I put that to both pieces, so 1 squared over 4 squared, so that becomes 1/16. Same thing with the power of 3. Each piece gets the exponent, so 1 cubed over 4 cubed, which becomes 1/64, which is 0.016. So the last one started really low, right, when my base was a 3. Started really low, and then it jumped up really fast. Let's see what this does. Negative 364 is like up here, right? So this one started very high and then worked its way down closer to the x-axis. So it looks like when my base is a value bigger than 3, we start low and then we jump up. When my base is in between a value of 0 and 1, we're going to start tall and we're going to work our way down. All right, let's explore here what happens when my exponent is a negative. So I have 5 raised to the negative x, all right? So here we have 5 negative, and now my x is negative 3. So 5 raised to the negative 3, well, that's just saying 5 to the power of 3, which is 125. 5 raised to the negative 2, that's 5 squared, which is 25. 5 raised to the negative 1 is 5 to the first. 5 to the negative 0, negative doesn't do anything, it's still just 1. 5 raised to the negative 1 power, all right, so now we have 5 negative 1. Remember, that flips it over, so it becomes 1/5. Negative 2, that's 5 to the negative 2 power, which means it becomes 1/5 squared, which is 1/25. And then 5 to the negative 3 becomes 1/5 cubed, so 1/125, or 0.008. All right, so this one also, remember this was like way up here. This one also starts very tall and then works its way down. So that starting high and working our way close to the x-axis. Notice it glides right on top of the x-axis. It doesn't actually cross it. That's important. That'll happen with our logarithms also. When our base is in between 0 and 1, and when our exponent is a negative, that seems to happen. All right, let's see. Oh, here we go. Here's something new. We have 2x, 2 to the power of x, and then plus 1. So plus 1 last time shifted things up. Let's see if that still happens. Does it matter if my function is now an exponential function and not a line? Or not a quadratic? You know, does that change the transformations that we're used to? Let's look. So we have 2 to the negative 3 power, and then we have plus 1. So 2 to the negative 3 power, that's 1/2 cubed. That's 1/8. I'm going to change 1 to 8/8. That becomes 9/8, which is 1.125. All right, do it again for the negative 2. So 2 to the negative 2 power plus 1, that becomes 1/2 squared, which is 1/4. I'm going to change that 1 to a 4/4. That is now 5/4, so about 1.25. Negative 1, 2 to the negative 1 power becomes 1/2 to the power of 1. So that becomes 1/2 plus, I'm going to do 2/2, gives me 3/2, or 1.5. Power of 0, 2 to the power of 0 plus 1, that is just going to be 1 plus 1, so that's 2. 2 to the power of 1 plus 1. 2 to the power of 1 is 2. Plus 1 gives me 3. Now I have 2 squared plus 1. 2 squared is 4. 4 plus 1 gives us 5. And then 2 cubed is 8. 8 plus 1 is 9. So look at this one. This one is now hovering over where y is equal to 1. Okay, it's hovering over this. Okay, it's going to happen. This is something we're going to call an asymptote. And it's going to happen in my logarithm graphs also. Okay, so exponentials have an asymptote. That's where my graph is leveling off. It's like an invisible electric fence that we can't cross. Okay, so we're leveling off somewhere. And my plus 1 moved that electric fence up 1 unit with the function. Okay, so here we go. What is this? Negative 2. Negative 2 to the power of x. Let's see what this does. So now my base is negative, but my exponent isn't. So if I have negative 2 to the power of negative 3, that flips it over, right? It becomes 1 over negative 2 cubed. We're still negative here. 2 cubed is 8, so that becomes 1 over negative 8. So there is still a negative as part of my answer. So that means negative 2 raised to the negative 2 power is going to give me 1 over negative 4. Negative 1, so negative 2 to the negative 1 power is going to give me 1 over negative 2. Still raised to the power of 0. Because there's a negative outside, remember we do that after your exponent, order of operations. So do exponents first, and then our negative. So it becomes negative 1. Negative 2 to the power of 1 is going to keep it negative 2. Negative 2 squared, again, we do the exponent first. So 2 squared is 4. This one now I have negative 4. And then negative 2 to the power of 3. I do my exponent first, then bring my negative in, which is negative 8. Okay? If there were parentheses, if this base would have looked like this, my answers would have been different. Okay? Because then you're taking the exponent to all of negative 2. Right now, no parentheses. The exponent only goes to the number 2, and then you bring the negative in. Okay? So watch out. Parentheses matter big time. Like here, negative 2 to the power of 2. Well, that's negative 2 times itself. So you get positive 4 out of it. But because there's no parentheses here, it only went to the 2 and then a negative. Okay? All right, we have each point. So here, all right, so what happened over here? Looks like there was a reflection over the x-axis for this problem. Okay, it got flipped. It's now starting at the x and then it's falling down. So it's a reflection over the x. All right, we have 2 more. Now let's see what happens when we multiply by something. So 5 times 3 to the power of x. Okay, so 5 times 3 to the negative 3. We already did this in, which one? This is our first one, right? Yeah, number 1, we already made the table to 3 to the power of x. Okay, so because I have that, I can go back and I can multiply each one of those by 5 because we already made it. But I'm going to show it to you by hand in case we hadn't already made it. So this is going to be 5 times 1 over 3 cubed. So that's 5 times 1 over 27. So that becomes 5 over 27, which is 0.185. I'm looking at the chart. When we did 3 to the negative 2 power, we got 1/9. Multiply that by 5, and we're going to get 5 over 9, which is 0.56. 3 to the negative 1 power was 1/3 times 5 is 5/3, 1.6. 3 to the 0 power was 1, and then 1 times 5 is 5. 3 to the power of 1 is 3, times 5 is 15. 3 to the power of 2 is 9, times 5 is 45. And then 3 to the power of 3 was 27, times 5 gives us 135. So this one starts real low, and this one jumps up real quick. Real fast. Okay. So it starts very low and it jumps up very, very quick. Now let's see what happens when we multiply by a number that is less than 1. So now we have 0.5. So here, raised to the power of 2x, we did 2x in our warm-up, so we also already have that table written down in my notes. I'm going to go back to my warm-up. In my warm-up, we didn't go to -3, so let's do that one real quick. 2 to the -3 power. You want to do 0.5 times 2 to the -3. All right, that becomes 0.5 times 1 over 2 cubed. That's 0.5 times 1 over 8. Okay. 0.5 is the same thing as 1/2, right? So that's saying 1/2 times 1 over 8. When we multiply fractions, we go straight across. That becomes 1 over 16, which is 0.0625. All right, in my warm-up table, we already did 2 to the power of -2. That was 1/4. So here I'm going to do 1/2 times 1/4. So that becomes 1 over 8. To the -1 power, we already did that. That became 1/2. So we're going to do 1/2 times 1/2, which is 1/4. The power of 0 was 1. 1 times 1/2 is going to be 1/2 for 0.5. 2 to the power of 1 is just 2. So we're going to do 1/2 times 2 over 1. So that becomes 2 over 2, which is just 1. Here, 1/2 times 2 squared. That's going to be 1/2 times 4, which becomes 4 over 2. We take half of that, we get 2. And then 1/2 times 2 cubed, which was 8. That becomes 8 over 2, which is 4. So these start low and they also grow up quite quickly. Okay. So we just did a whole bunch of transformations. Okay, so let's go back and see exactly what each transformation did, what we did to each piece. So what did we notice? Okay, so on the very first, our number 4, graph number 4, right? On graph number 4, we added a number to the end, and that's going to shift my graph up and down. Okay, so adding a number to the graph is going to shift it. If that number was negative, so if it was -1, it's going to shift down, right? All right, what else did we see? In graph number 5, okay, when we had a negative being multiplied to my base, it reflected the graph over the x-axis. Remember, that one got flipped upside down. All right, graph number 3, that was when we had 5 raised to the -x, okay? I'm gonna write that down. So here, this is referring to 2x, and then we had +1 on the end. That's when the graph is going to shift up. Graph number 5 was when we had the negative with my base. Graph number 3 is when we had the negative in the exponent. Okay, so that's going to reflect over the y-axis. So remember, it started high and went low. It got flipped sideways like that. All right, graph number 6 showed us that if we multiply by a number, it stretches the graph. Remember, this one jumped up real fast, real quick. This was when we multiplied it by 5. It was 5 times 3x. Okay, it jumped up very quickly. So it stretched the exponential graph up. Okay, it's also going to change the y-intercept to the number you're multiplying by. So if you go back to that graph to number 5, let me go back to number 5. I'm going to show you number 5. Okay, number 5, here we go. So notice in our graph, well, that's not number 5, is it? Number 6, I'm sorry. Where we multiplied by 5, there we go. Here, on this one, notice our y-intercept. Right here, it is 5. That became what we multiplied it by. Because our y-intercept in the beginning, it will always be 1, right? Because that's showing an exponent of 0. So parent function has a y-intercept of 1 every time. But if we multiply it by something, that's my new y-intercept. Okay, so graph number 6 shows us the stretch and how my y-intercept is going to change. All right, and then lastly in graph number 7, and this one we multiplied by half, so this is a compression. So this is when we had, where did I come out here? I'm going to put it over here, 0.5 times 2x. So here we multiplied by a value less than 1, but bigger than 0 still. That's going to compress the graph, so this graph did not grow as fast. It grew quite slow. Let's go back and see it. This one. So see, it was very slow to move its way up. Okay. And again, my y-intercept changed, and my y-intercept changed to be what we were multiplying by. Okay. So these are all the transformation rules. So I would make sure I had those written down somewhere where we can refer to them quickly. These are the transformation rules because since logarithms are the inverses of exponentials, it's going to follow the rules maybe the same, maybe opposite, because inverses are opposite. I don't know. We're going to wait and see. But they're going to be tied in. They're going to relate. Okay? So, your homework. There we go. I want you to do 7 through 21, but only do the odds. Okay, so you don't have to do the evens if you don't want to. If you want extra practice, have at it. Okay, but you don't need to do the evens. You are graphing everything, so please make sure you have some graph paper, or you print some graph paper, or you just sketch it very nicely. Remember to use your t-tables to help you make each graph, and also the transformation rules that we just wrote down so you can kind of expect what to see. When you get down to 17, 19, and 21, there's more than one transformation occurring. So just be aware of that, be patient, make your t-tables, follow order of operations. Like for 17, when you plug in values for your exponent, you do the exponent to 1/3 first, then you multiply that value by 5, then you subtract 8. Okay? So be careful, pay attention. You got this. I will see you on Thursday when we start doing logarithms and see how all this relates to each other. All right?